So now we are going to start with an important property, that is the variable oxidation state. So what we have seen actually in the d orbital, that in the transition series we know that there is a continuous filling of an s orbital and the penultimate shell, that is the n-1d shell. And as we all know that when we talk about the transition series, there is hardly a difference between the S and this penultimate shell. There is no, you can say that there is no lot of, you can say that the energy difference between them is not too much. So that means whenever there is a bond formation, there is the participation of this electrons also, and there can be a participation of n-1d electrons also. So that means these two shells electrons can actually participate. But what we see that sometimes only the S ones are participating, in the something only this thing is participating, and in the few what we will see that the both of the electrons are participating. So depending upon that how many electrons are actually participating in the bond formation, the oxidation state is going to be that. Suppose if the participation is only of one s electron, so then the oxidation state is going to be +1. If the participation is for 2 electrons, we can have +2, and if there is 2 from this and 1 from this, it is going to be +3. So likewise we can have many electrons involved in the participation in the bond formation, and likewise we can have the variable oxidation states. So this is actually an identification property for the transition elements, as they can show variety of oxidation states actually. So this is what I have written here for you. Just look at the board. That variable oxidation state, we know that it is oxidation state is indicated by the number of electrons that are going to participate in the bond formation, right? And although we know that they are going to donate electrons, so they are going to obviously going to possess a positive oxidation state. This we don't have any you can say we are just confirmed that obviously they are going to show a positive oxidation state. Now what is the reason that they show variety? As I told you that they show variable oxidation state, the reason is that in addition to NS, the penultimate shell is also participating in the bond formation. And and what is the reason behind that they both can participate? A small energy difference, that is the small energy difference. So just depending upon the number of electrons that are going to participate, that is going to indicate the oxidation state. So we have seen that they can have the oxidation state from the lowest to the highest, and in middle we can have the intermediate one also. Lowest oxidation state is just determined by the NS electrons, right, and the highest by the participation of S as well as the D electrons. So this is what we have seen. This I have written for you for first transition series. See, we have this thing scandium, titanium, vanadium, chromium. See that how variety of oxidation states actually they are showing. Scandium can show +3, titanium can show +2, +3, +4. Vanadium can also show this 4 kind of states. Chromium can show this again 2, +2, +3, +4, +5, +6, and all of them actually can show a variety of oxidation states. They're just depending upon that how many electrons are actually participating in the bond formation. So whenever somebody is going to ask you about that which element is going to possess the lowest oxidation state, you are going to answer in that way that the number of electrons present in the s orbital is actually going to determine its lowest oxidation state. And you must be thinking that I have enclosed few oxidation states in brackets. You know that what actually it means here? It means that these bracket oxidation states occur very rare. These oxidation states, though they can show actually, but the occurrence is very rare. Like the element occur in these compounds in fulfilling these oxidation states are actually very rare. So after scandium, like if we observe in first transition series, the common oxidation state is +2. The common oxidation state is +2, because as we know that in this case we have NS2 and this thing N-1D will be filling from 1 to 10. Right. So the common one is +2 except scandium, right? For scandium can actually show +3. But after that, +2 oxidation states become more stable. The reason being because as we move in the period, the d orbital is actually gaining extra stability. So the release of electrons from the d orbital is somewhat slightly difficult, but though it can show the variable oxidation state, so that means they can actually participate. But still, if we talk about the common thing, commonly the common oxidation state that is observed, that is +2. And if somebody is going to ask you that how when you move in a period, +2 oxidation state becomes more stable. What is the reason behind? So you are just going to have a quick answer that after that the d orbital is actually gaining somewhat stability. So the loss of electrons merely occur through a s orbital instead of n-1 d orbital. But though it's not like that, it's not strictly like that, the electrons are not going to get removed from the d orbital. It can happen actually. But if we talk about the common observation, then it is the participation of the ns electrons, that is the +2 oxidation state. And one more thing, see, the compounds with oxidation state +2 or +3, they mainly form ionic compounds, and the compounds showing, the element showing higher oxidation state is going to form a covalent bond. This you actually know already. And if we talk about the agents, the compound with higher oxidation state, that means it has actually utilized all its electrons in bonding. So now it is in search of electrons, it needs electrons now. So that means it is going to act as an oxidizing agent. So whenever a metal is present in its highest oxidation state, that means it is a powerful oxidizing agent. And if it is present in a lower oxidation state, that means it still possesses the number of unpaired electrons which it can lose actually. So it acts as a reducing agent. So you should know that when a metal is going to act as an oxidizing agent and or when a metal is going to act as a reducing agent. So it should be clear that whenever the metal is present in its highest oxidation state, it is going to act as an oxidizing agent, the better one. And when it is present in its lower oxidation state, it is obviously going to act as a reducing agent. So this is what is the variable oxidation state, and it's very important topic because this is the important property actually which is shown by the transition elements. Neither the s block nor the p block, only the d orbital is that which show these variety of oxidation states. So you should know this. So as I have summed only a few oxidation states for you, but try to do it for the second transition series, third, fourth transition series, because you should know actually that which metal exhibit which kind of oxidation state in the variety of compounds, right. So this is what is the variable oxidation state.